read you the new madlibs. Once upon a time in the bizarre land of Count Chucklefritz, a chartreuse wizard named Woldy cast a spell on his airy hat. Suddenly, the hat started sneakily dancing and singing angrily. It was so speedy that even the Jeff Bezos joined in the fun. The wizard laughed terrifyingly and exclaimed, "This is the most snoozy party ever!" Everyone in the land continued to coldly dance until the sun set behind the Captain Snickerpants Mountains. So I'm pretty happy with this. It's more funny to see the places where you inserted the words for the madlibs, right? So. And also, I didn't like how the prompt came up right afterwards. So I had it wait for a key. So if I press space, then it exits out. So that's kind of nice. If I had more time, I'd probably go on to ChatGPT and let's see what ChatGPT has to say, right? I went on to ChatGPT last night and it wrote the madlib that I wanted. So you can see here I asked for adverbs and proper nouns and it pretty much just did those. So if I did another one, I'd want a lot more verbs because verbs are a lot of fun in madlibs, and just fewer adverbs and more nouns and verbs. So that was how I made the madlib. But anyways, I just wanted to show you can take tools like this and use them as inputs for your programs. So let me show you how I actually transformed this text into code. So let me clear this. So the way I did it was I have something called a record, which is kind of like a bundle of information, and I declare it. It's more like a form you would fill out with different spots to write things. And so if I make one of these records, which is called a part, then I can assign these variables inside of the part. These are called fields. And then I can carry this whole part around and have these two associated things be together in there. And so at the bottom of the program, which I get to by this line here on line 70, go sub 1000. So this is going to jump down to 1000, run all the lines of code down there, and when it sees a return statement, it's going to come back and continue on line 80. That's what go sub does. So if I go down to line 1000, you can see here's the text of the madlibs, right? And so I'm just creating data elements in a big, gigantic list. It's called an array, right? And I'm saying begin array. And so all of these lines will get plopped into madlibs. And then I can use that madlibs array in the rest of the program to draw, to figure out what's a part and what's not a part, and that type of thing. So at the bottom of the begin array block, there's always something that ends the block. So that's the end keyword. So everything from here on line 1000 all the way down to here is going to be added into that array. And there's two types of things that I put into the array. I put in strings. So these are just parts of the paragraphs that don't change. And then I put these parts and then say what the type of the part is, which is this adjective. So you can give records initial values that differ from the initial value in the record declaration. So the initial value is normally an empty string, but NM is the first thing in the record. And so if I set that first thing in these parentheses right here, then that becomes the initial value in that name of the part. So anyways, this whole thing is just basically a list of these data values, and then my program just loops over them a bunch of times. The first time I loop over them, I will go through and I'll figure out which of these things is a part, and I look at and I see, is the type of the thing in the madlibs a record? If it is, then I think it's a part, and I say, I print out, can I have a, and then that first thing which says like adjective or proper noun, question mark, and then I say get string, and I put the value of what the user types in into the VL slot in that record. See? So the part starts to build up the values, or all of the parts start to build up the values as we go. So that's the first loop, is just setting all the values in the madlibs. The second loop is to build up the entire set of strings, whether it's a part or it's just the strings that were not parts, into a giant string called F. And so what I do is I loop over these madlibs again, and I say, if it's a string, we'll just add that to F. If it's a record, well then, add in the coloration, that's what this is here, and then add in what they typed in, Lady Chuckleworth, right? And then switch the color back to what it was before. And then I add all of those words with spaces between them. Okay, so why did I put spaces between them again, right? The reason why is because now I need to figure out, when I run it, like when should I do a line break? When should I go to the next line, right? And so what I do is I split the entire F string on space, and what that'll give me is an array of just the words that are in F, and it'll eliminate all the spaces, right? And so what that gives me then is an array that I can loop over called words. And so I loop over the words, and this is what we were talking about earlier, where it's like, I didn't like how it had a space between the comma because it thought this was a word. And it's like, no, it needs to hug the previous word, right? So that is how I do that. And then what I do is I say, okay, if my cursor is not at 0, so if it's a non-zero, that's what this is saying. If it's basically greater than 0, then I want to figure out where the cursor would be if I added my word on the screen at that position, right? And so if I go over the right edge, I know, okay, I need to add a new line before I print the word. Otherwise, it'll wrap around, it'll look terrible, right? And so that's what I'm doing here. I'm saying there's 40 columns on this screen, and I'm saying, hey, if you get to 39 or more, I want you to do a new line. There's still some corner cases where it'll still not look good, but I lucked out and my madlib is right. And there are things you can do to mitigate that, but I'm pretty happy with the way it runs. And then here's that spot where I say get key. Finally, I say quit false. If you don't say quit false, it'll actually print out the line where it quit, right? So let me show you that. Run 190. Okay, get key, pressing spacebar, And see, it shows you it stopped at line 390. So that's kind of useful from a debugging standpoint. If you want to debug and know where it quit, then you can print that way. If you don't want to know where it quit, if it's just like you want it to quit in an orderly fashion, then you would say quit false. So that's sort of the rundown of our little program that we wrote. I'm pretty happy with it. I hope you found it really interesting, and go ahead, type it in yourself and see how it goes. And it's working pretty well. It's getting a job done. And yeah, so that's it.